Hello, wonderful class. Mr. Algebro here. In this video, I'm going to take you through a review of the laws of exponents. And so here we go. Make sure you subscribe to my YouTube channel for more great videos like this. So this is what we're talking about. If we're going to multiply expressions like this together, then some of you maybe know that we're supposed to add the exponents. So 2 plus 1 plus 3 is 6. So this would be equal to x to the sixth. Now, why is that? That's because we can factor this to make it x times x. And then here's another x that we're multiplying. And then here are 3 more x's. And how many x's do we have total? 1, 2, 3, 4, 5, 6. So x to the power of 6. Just like if you had 5 squared times 5 cubed, you could write it as 5 to the 6th power. Okay, so that's first example, and that is called the product property of exponents, or the product law. Okay, whenever you have the same bases, you keep the base and you just add the exponents. Okay, these are not formulas that I'm going to let you have like on a formula sheet. There's going to be a lot of them coming. They're laws that you have to know. Okay, so just practicing that same law, if I'm going to multiply these two together, then when you have constant terms, they just work like normal multiplication. So 2 times negative 5 is negative 10. And then these two multiply together to make x to the 6th, because 2 plus 4 is 6. And then y cubed times y squared is y to the 5th. And this is all multiplication, so I don't have to write these times symbols. I can write it like this, and it still means this is one term. It's called a monomial. Okay, and it's all multiplied together. Okay, on to, that's still a product law. So now on to division. This is going to be called the quotient law. So if I were to, again, write these out as factors, this would be 5 p's multiplied together, divided by 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know from division that if we have the same thing divided by itself, it equals 1. So I can divide all of these out and get 1, 1, 1, 1, and 1 left on the top. But how many p's are left on the bottom? 4. So 1 over p to the 4th, which makes some of you think, oh, maybe we can subtract. What if I had just done 5 minus 9? And that would give me p to the minus 4. Maybe you know this property. It's called the quotient property that says, yes, we can do that. We keep the same base and we subtract the exponents. So that means that these two things are equal to each other. 1 over p to the 4th is equal to p to the minus 4, which brings up some kind of weird things that happen. Like, what if p was 3? So I had 3 to the minus 4. This is not a negative number. This is 1 over 3 to the 4th, or 1 over 81. So negative powers are not negative numbers. This is going to be greater than 0. And then if I use this quotient law that says I can subtract exponents, what's going to happen here? I'm going to get y to the 5 minus 5 is 0. Okay, but then we also know that anything divided by itself is equal to 1. So this means anything to the 0 power equals 1. So 1 to the 0 equals 1. 2 to the 0 equals 1. 8 to the 0 equals 1. Anything, when I raise it to the power of 0, equals 1. I know your minds are blown right now. Okay, so then, we've got this zero exponent property and negative exponent property. So here, again, I can show that I would have 5 y's on top, 4, 5, and 6 on the bottom. 3, 4, 5, 6. So there's going to be 1 left when I cancel everything out. So it's equal to 1 over y. And this is also equal to y to the minus 1, because 5 minus 6 is equal to negative 1. So this is another thing that's going to come up all the time in this class in algebra. If you have an expression like 1 over x equal to something like 5, and we want to figure out what x is, then like I could multiply both sides by x. I could get 1 equals 5x and divide by 5. So x is 1/5. But I kind of already know that from this property. If 1 over x is 5, 1 over x is really x to the minus 1. So then I already know x has to be 1/5. If I take 1/5 and raise it to the minus 1, this is the same thing as 5 to the power of positive 1. Because this negative exponent, it says to flip this fraction around, and then it becomes positive. Okay, so we'll practice some things like that as well. Okay, so there's the negative exponent rule. Basically, negative exponents are reciprocals. Reciprocal. Okay, so if I had 3 to the minus 2, then that would be 1 over 3 squared, which is 1 over 9. Or if I had, even if I had a fraction like 1/2 to the minus 4, then I do the reciprocal of this fraction, and then I raise it to the 4th power. So 2 to the 4th is 16. So just a few quick examples of how that works. Okay, moving on, we have another property. When you raise a power to another power, then we multiply those together. So this would become a to the 20th minus 5a to the 20th, and then we can simplify. 1 minus 5 is negative 4a to the 20th. Okay, so then we could see, why do we multiply those together? So if I had a to the 4th to the 5th power, that means I would have 5 of these. And then we know from earlier that what do we do with these exponents? We add them all up. So 4 plus 4 plus 4 plus 4 plus 4 is 20. Similarly, if you had like x cubed squared, then this would be x to the 6th power, because I have x cubed twice, and 3 plus 3 is 6. Okay, so then that means this one, instead of writing this term out 3 times, I can just raise everything, sort of like distributing this exponent to everything. So negative 5 cubed, and then I have p, 2 times 3 is 6, and 4 times 3 is 12. And then I need to simplify this. Negative times a negative times a negative is a negative, and 5 cubed is 125. Okay, and then I can write out the rest of it. Oops, somehow this p is turned into or this s turned into a p. So that should be s to the 12th. S. Okay. Almost done here. Oh, there's the power property that you can't see. See if I can erase. Yeah, there you go. There's the power property if you want to pause and copy that into your notes. Okay, then we have one more property. If you have a fraction raised to a power, then you essentially distribute the power to both numerator and denominator. So a simpler example, like if I had 4 over 3 raised to the 3rd power, then I would do 4 cubed over 3 cubed. So 64 over 27. So with variables, then I just make sure I distribute the power to everything that's there. So negative 2 to the 4th, m to the 4th, and n to the 4th. And then I can simplify. Negative 2 to an even power would be positive 16 m to the 4th over n to the 4th. Okay, and then we can combine the negative exponent rule with this fraction rule. So the long way of thinking about it is distributing the exponent, which then kind of becomes a bit of a headache when you have two negative exponents. So I wouldn't do this even though it's not incorrect. I would use this one first. And if you have negative exponent, again, that means that these two are going to switch. So first, just rewrite it as 3 over a, and then that makes the power change to plus. And then it's a much easier problem to solve. I get 9 over a squared, okay, which is the same thing I would have had over here. I just would have had to think completely differently about it. And maybe I'll do that just so you can see. Maybe you like this way. Whoops. That should be 3 to the minus 2. Okay, so then that minus 2 is going to flip. It's going to flip everything. This a to the minus 2 is going to become 1 over a to the positive 2. And if you have a negative in the bottom, then it switches to the top and becomes positive. And so we end up with the same thing that I had in this step. So I would go ahead and switch the reciprocal first. Another maybe quick example, like if I had x over 8 and I had to do negative 3, then I would switch this first 8 over x and raise it to the positive 3. So then you have 8 cubed over x cubed. And you can multiply 8 times 8 times 8. Okay, so that is it for our laws of exponents. I had a couple more examples, just harder problems. These would be examples that I give you to work on. So you should be, there are a couple of quizzes that I want you to work on. After these problems, I can just go through them. Maybe there will be something similar to work out. So again, a fraction raised to a power. So I have to apply this power to everything I see. So negative 4 cubed, x squared to the third power is x to the sixth. X cubed to the third power is 3 times 3 is 27. And then 4 times 3 is 12. And then I need to simplify this one as negative 64. And sometimes you can go a little bit further. Like here we have x to the sixth over x to the 27th. And we know we can subtract these. Or you can just leave more of them on the bottom. So this one can completely cancel out. And 27 minus 6 is, wait, no, I can't do any subtraction right now. 11? No, 21. And just leave those 21 on the bottom. So x21 times z to the 12th. And this would be the fully simplified version, because mathematicians really don't like negative exponents. We'd rather, like, instead of writing x to the minus 21 on the top in the numerator, we'd rather have the positive in the bottom. Okay, so watch out for that in the assignment. Always make sure you leave, if you get negative exponents, write them as positive exponents like this. Okay, and this one's just a little bit of fun. Since we know anything to the 0 is 1, then this just becomes 6 over 1 plus 1. So that's 6 over 2. So this is equal to 3. Okay, go have fun with the assignment. Thank you for watching. Mr. Algebro out.